Good afternoon. This is Francesco Incelli from MIDAS IT UK. Thanks for joining us to this webinar regarding the construction stage analysis. The the content of today are going to be mainly related to trying and understanding a bit more how to read the construction stage interface, how to manipulate and create the groups, which are very important for construction stage analysis in MIDAS. We will go through an example of setting up a construction stage for a small bridge, and then how to modify the sequence, and also highlighting how this process is quite easy if you understand how to operate on the groups in MIDAS Civil. Let's switch to the actual model and let's have a look what I've prepared for today. So the model that we have here is an example, a very small example of a cable stayed bridge. This is the way the bridge looks like. It is a simple structure, but it will allow us to go through all the ways and basically to analyze a bit more in detail all the challenges related to construction stage analysis. For the sake of this model, I've done some preliminary modeling, which involves obviously having the materials for the beam elements and for the pylon and for the cables. And also I have already defined the time-dependent material properties. I'm not spending too much time on this because there are a lot of webinars that we've done in the past and also tutorials on how to define time-dependent material properties like shrinkage and creep and compressive strength development. But that's the, for showing purposes, that's the material property that I modeled. And then, as I said, compressive strength. And also sections. I've already created them and assigned them to the model. And I didn't apply any static loading for the moment because we will do it as part of this webinar, and no construction stages whatsoever. Right, when it comes to setting up your construction stage analysis, you have to have in mind, obviously, what the sequence will be for you to create the groups. Let's have a look how to access the construction stage control window, which can be accessed by the quick icon right next to the base model drop-down menu, or it can be accessed in loads, construction stage, and define construction stage. Now the window is blank, obviously, and we can generate the load cases by clicking on generate. And this is a window which allow us to create automatically like a number of load cases based on what's the requirement. And we can set up the name of it. In this case, I'm just going to set up the name as CS. And the suffix field allows you to create automatic numbering from 1 to whichever number you want for you to create like a list of load cases. In this case, I'm going to do CS from 1 to 15 for the type of load structure that we are going to model, because the sequence will involve 15 stages. We can set up a duration for each stage. So let's say each stage is lasting 10 days. And we can also set up a number of intermediate steps if we want. So in order for us to set up the steps, you can either type the day number in the field here and add, or you can generate, for example, step number 2. So I'm going to generate 2 intermediate steps from the starting step of the stage and the last step of the stage. And I will generate steps. So these steps are going to be generated, which means the software will subdivide the stage into a initial step, then step 1, which is the day 2, step 2, which is day 5, and then the last step, which is going to be day 10. We can also decide whether we want to save the results for the stage or not, because we might want to do the construction stage analysis and then just be interested in the last stage instead of all the previous ones. But in general, we are interested in keeping the results for each stage and in many cases for the additional step. If you don't activate those two, you'll be able to read the results from the construction stage analysis only for the last step. Now, obviously, I'm interested in having stage saved and additional steps saved. If you don't activate additional steps, you will be able to see only the results for the first step of the stage and the last step of the stage. Now, once this is done, if I click OK, you can see how the list has been completed. So I have all my construction stages numbered with duration of each one of them and date, which is basically the accumulated age of the structure, and then number of sub-steps. We can always click on the stage and click on Modify and Show, and basically change all the additional steps and all the information that we have input already. Now, looking at CS1, which is going to be our first stage, we will briefly go through the important part of it, which is for each stage, which is the element, boundary, and load fields. So these are the main three concepts that we have to familiarize with when it comes to create a construction stage analysis. So for each one of the steps, we will be required to tell the software which elements are active at that stage, which boundaries are active at that stage, and which loads are active. There is also an option for deactivating elements, boundaries, and loads, because the loading conditions may change in between one step or the other. And also the elements will change between one step and the other. Looking at the elements, once we will have look at practical application, but once we will have created all the element groups, those will be listed in this field here, and we will just select and move them into the into activation or deactivation tab, whether they are active or inactive. Something very important is the age of the element. So if you are using, let's say, concrete elements, the age is critical, because that's the parameter for the age is going to influence the strength of the concrete and the stiffness of the concrete element. So let's say I am activating elements, concrete elements, and stating an age of 0, I'm basically doing something wrong, because the stiffness of the concrete would be 0 and the analysis is not going to progress. But we will have a better look at it when we go more in depth into the modeling. For deactivation, the redistribution percentage of the force applied onto that element which is deactivated can be also modified. So if you want the full loading which is on an element to be transferred at the adjacent elements when there is a deactivation, then you can specify 100% or a different percentage according to your analysis needs. In terms of boundaries, once you create the list of the boundary groups, those will appear in the group list. And then the options for activation are whether you want to activate the boundaries with at the original coordinates or at deformed coordinates, and whether you want to deactivate the group. In terms of the loading, again, those load groups will appear once they are created in the list. And we can decide whether the loading is active at the first stage, first step, the last step, or the intermediate steps. So loading can be activated or deactivated at intermediate steps within the stage. This is just a preliminary discussion regarding this, and now we will go through the practical example to see a bit more what to do when it comes to doing the construction stage. So I'm going to close this one because we're going to just think a little bit about what kind of element groups we need and how many boundary groups we need and what load groups we need. In terms of construction of this bridge, the pylon is definitely going to be built first. So the pylon and all the elements related to the pylon, they are going to be assigned to one group. Now, how do I do this? We will access the group editing window either in the tree menu, clicking on group. So you can see in the tree menu there are 4 main tabs: tables, works, group, and reports. So we're gonna click on group, and we'd be able to see how many structure group we have and how many boundary groups and node groups. Right-clicking on structure group and clicking on new with the ellipses next to it, we can now create the group by setting up the name. So let's say we need a group for the pylon. So we will call this the first group pylon. There is no need for a suffix because the pylon in this example is going to be built just in one single piece, but in reality, depending on the size of the structure, you might have, like, I don't know, 10 different groups for the pylon, because the pylon might be quite tall and you need to build it in different stages. But this is going to be like too complicated for the sake of this webinar, so I'm just going to stick to the case of a pylon being done in one single step. And I will add it to, and I will add this group on the list. So now the group is empty. We will have to fit it in later. For the cables, we have 1, 2, 3, 4, 5 cables, and we will assign to them different groups because it is quite obvious that they will be installed and stressed at different stages. So I'm just going to create suffix 1, 2, 5. And then add, so you can see how the list is populated straight away. For the deck is going to be built from this end here to this end there. So let's say the first 3 segments are going to be built in situ, in just one go on temporary supports. So these are going to be part of one single group. And now we'll call this one deck deck 1, but then we will have the second segment, which is deck 2, the third, which is deck 3, and then deck 4. So I'm just gonna create deck 1, 2, 4 and add. And this should be all that I need for this structure to activate or deactivate the elements. And now I'm gonna close and do the assignment. So what we said was the pylon is going to go first. So there are different ways of selecting elements. As now in this model, the section for the pylon has been already assigned to the elements. I can double click on the section, select all the elements on the piles, and I'm going to just activate them to see also which nodes are connected to the pile itself. Why I'm doing this? Because I want to make sure that I include into the group the elements and also the nodes associated with it. Once they're all selected, I will click on the pylon group, drag and drop, and you can see how now this group is filled in with 6 nodes and 5 elements. So the group is now assigned. Let's go back to the full model by clicking on Activate All. And let's see, well, for the cables, we're going to select cable 1 and then click on the cable 1 group, drag and drop, and now one element has been added. Select cable 2 and repeat the same exact process for the whole set of cables. One thing that I want to mention is that this procedure of assigning groups to elements and load is applicable to any type of structure. So don't sort of think that as I'm showing a cable stayed bridge, this is the procedure to be applied to cable stayed bridges. This is a general procedure that can be applied to any type of structure. cable 5, then it's done. If I want to quickly see what kind of assignment I've done, I can double click on the groups and just double check that everything is assigned correctly. Now, let's proceed with the deck, and we're basically done, because what we're going to do is to select the deck from the, let's say, the extreme left-hand side to cable number 3, and this is going to be deck 1. Then the second segment is going to be deck 2. So the third segment is going to be deck 3, and then the last segment is deck 4. So the groups are now defined. As you can imagine, we will call this group in the list within the construction stages. Now, after the structure groups, as the software suggests as well, it's time for boundary groups, for generating the boundary groups. This is something that requires attention and also a bit of judgment when you do it, because if you activate or deactivate the wrong boundary groups, then the structure will not be analyzed correctly. So we need to spend a bit of thought when it comes to creating the groups, and also thinking about what the sequence is for you to create the groups. An example would be that in this case, we will have in this end, which is the extreme left-hand side, there is a permanent boundary, which is going to be similar, well, permanent, as the one at the extreme end on the right-hand side. But this boundary is going to be activated at one stage, and this boundary is going to be activated at one stage, so the support conditions. This means that even if they are permanent boundaries, we will have to assign them to two different boundary groups. So let's start doing this really. So we will need one boundary condition for this node there, one boundary condition for this node there, some intermediate supports which are going to be temporary for these two nodes, and then obviously boundary condition for the pylon. And don't forget that in general, but this is related to the capacity bridge, there is a bearing in between the deck and the pylon, or some form of connection in between the deck and the pylon, which is now represented as an elastic link in this model, which is going to be assigned to a boundary as well. So any boundary condition to be accounted for in a construction stage analysis must be associated with a boundary group. Anything which is not associated with a boundary group is not going to be taken in account. So let's start the process of creating those boundaries. So we have, as we said, one boundary for the pylon that I will call pylon, and then add. We have deck left, which is the first permanent boundary group, and then deck right, which is the boundary on the right hand side. Then we have the temporary, which is going to be just one group, and also the elastic link. So these 5 boundary groups should be enough for us to model the full structure. How can the boundary groups be assigned to the boundary conditions? So supports or springs or elastic links. Let's start from the supports. If you remember at the start of this webinar, I said I didn't model the boundary conditions yet, except the elastic link. So what we're going to do now, which is the simplest way of assigning the boundary groups to the boundaries when you are modeling, is to click, for example, on define supports for the supports, and anytime you start modeling any boundaries, there is always a default boundary group name selected automatically. But if you click on the drop-down menu, you can see that all the groups that we created, they are there. Now I'm going to apply to node number 1 a pin boundary condition. So I'm going to restrict all the translations, and this boundary is going to be deck left, and then apply. So now the boundary has been applied and the group has been applied at the same time. So this is the easiest way. If you sort of sit down and sort of think about how to develop your model, you will end up with your model correctly set up and ready to be run at the end. Let's move on into assigning now the boundary on the other side, which is node 22 in this example. And this time, this is going to be deck right. It doesn't have to be a pin, but for the sake of this example, it's going to be just a vertical restraints, just a form of bearing. I will call it deck right. And assign it. So now this is assigned as well. I'm going now to assign the pylon. So change the group name, select the node, which is at the bottom of the pylon, and restrain obviously translations and rotations. And assign. So 1, 2, 3 boundaries are assigned. What's left for me to do is to do the temporary ones, which are going to be placed underneath the second cable and the third cable. So I will select them at the same time. I will change to temporary as the boundary group name, and these ones are only restrained for the vertical direction. And if I apply, then the full boundary conditions for the structure have been set up. It is always important that the groups are correctly assigned as well. This process for the boundaries is now finished, and what's left for us to do is to think about the loading. So what we will need in this structure, for example, are 5 groups for the loading of the tendon, because for the loading of the cables, because the cables that will have 5 different pretension loads, as you would expect. Then, according to the sequence, the number of load groups can change. In this case, we're going to have 3 construction boundary groups loads. So imagine the bridge is built in from node 1 to node 12, and then incrementally from 12 to 16, and then 16, 20, 20, 22, which means there's going to be on node 12 some form of construction loading related to constructing the adjacent segment, and so on. So we're going to have 3 construction load groups for the construction of the deck, and also 3 segment dead loads that we will have to add for some intermediate step. In general, this is now related to the type of bridge, but in general, you can set up as many construction loads as you want and as many load groups as are required during construction. So now I will do this in this model. And as we said, we need 5 tension loads. So I'm just going to go call the load group T, 1 to 5. And add. So these are going to be created. Then, as we said, I will need construction loading for the installation of the cables. And this one is going to be called, DC. The naming is absolutely not fixed. You can decide whichever naming you want. And this is 1, 2, 3. Then we're going to have the weight of the segments when they are being built, the self-weight, and this should sort of finish off the list of the loading, except that we have to add some superimposed dead loads if we want to include them in the construction stage sequence. And also, oh, sorry, I don't need them to be 3. It can be just 1. And also at the end in the node 22, a jacking load for the construction, because in general for this kind of bridges at the very end there is a JackUp load to be considered, JackUp, which I will call JackUp, and that's it. So these are the loadings that we will need to set up. Assignment of the load groups to the loading, it's done in the same way as we've done for the boundaries. So anytime we will start defining a loading, we can select the relevant load group to be assigned to it. Let's now start this process. So we go into loads, static loads, and self-weight, which is the first one that we will assign. So the load case name must be defined, but just bear in mind that load case name and load group name, they are independent, which means that when you assign a load group name to an element, to a load, the load group element sort of behaves like a load case for the construction stage analysis, but the load case can be recalled in the static analysis even after the construction stage analysis. So now we're going to assign self-weight. That's the load group name that I will select for the self-weight. And the direction is going to be -1. And then add. So you can see how the load case name is the one self that I decided previously, and the group is SW1. So anytime this group is called in the construction stage analysis, the self-weight is going to be activated. Next step is to define all the construction and pretension loading. Let's start with the pretension loading. So we go into temperature, pre-stress, and pretension loads. We will obviously change the load case into tension 1, which is the one that we want to create, and make sure that the load group name is correctly assigned. So for tension 1, T1 is the load group name. In a real scenario, I would also already know what's the value of that pretension, as I do now. So I'm just going to input the value of pretension that I've calculated previously and apply it to the, select the element and apply it to the element. Then I'm just going to go to the second one, so tension 2, change to T2, and repeat the same process, knowing what's the pretension load. Again, any assignment of the loading is the same in terms of the procedure of doing it, be it a temperature loading, be it a line loading, it doesn't really matter. Don't be confused by the fact that we are dealing with cables and pretension loading. That's the same assignment for every type of loading. So then we got tension 4, which is 7,900, and we will apply it to tendon number 4. And then tendon number 5, tension 5, 6200, and apply. So now these are generated. We can also, when we close, we can also check that the list of the static loads is being populated correctly. And if we right click and click on tables, we can see a very quick table in which the element, the load case, the tension load, and the groups are shown, just for us to double check that we didn't do any double assignment or something like that. Let's move on with now defining the superimposed dead loads. So I will select the deck let me just switch off the numbers. I will select the deck and go into load, static loads, and in this case is a UDL, so I'm just going to use element line load. Again, same procedure. Load case name is going to be whichever load case you decided for this load, and then load group name is going to be the superimposed dead load group name. The weight, depending on what you calculated, can be whatever weight it's needed. So in this case, it's going to be 10 kilonewtons per meter. And everything seems correct, so I can just apply it. Now the UDL is applied to this superimposed dead load group name with a load case name to second. It is time for us to set up now the construction loading, which so in order for us to assign the construction loading, as we said, there's going to be a construction loading on this node here, which is node 12, then 16, and then 20. So let's select the first one and go into, it's going to be a nodal load. So that's going to be the load of any machinery or any construction loading related to installing the cable. It depends on what kind of construction you're using. But I'm showing this just for to showing you how applying nodal loads and at the same time assigning to them load groups. So this load is going to be FZ minus 785, and the load case is DC, what we call DC. What I want to show you now is that even if the load case is the same, I'm going to assign 3 different loads to the same load case. But then I will give to those loads 3 different load group names. This means that for the construction stage analysis, these loads will be treated separately. And that's quite important and also useful, because you can set up a load case with many loads, but then if to the specific load you will assign a different load group, then in the construction stage analysis, they will be treated separately. The way of thinking about this is that the load groups for the construction stage analysis, they are like load cases. So now I'm setting up the load for node number 12, and it's DC1. So I will apply it. Then I will select the one for node number 16, and this is going to be assigned to DC2. So the load case stays the same, but the load group name is going to change. And then same thing for DC3. And then apply. So we can see them all together here, because that's the base model, which shows like the static load cases. But when the construction stage analysis will be set up, these loads will be treated separately. I will repeat the same process for the weight of the segments. So on node number 12, we're going to have a point load and a moment, which are -1700, and then my, which is 13750. So these ones will be applied to the load, that will be assigned within the load group name segment 1. So I'm just going to do that. Then I'm going to select the second one, which is segment number 2, and apply. Number 3 is going to be, obviously the weight changes because the portion of the segment is smaller compared to the previous ones. So this is going to be -860, and it's 3500. Segment number 3, and then apply. So these ones are applied as well. And then what's left is the JackUp loading, which is going to be assigned as a specified displacement. So in the static loads field, menu, you would click on specified displacement. Again, load case name, load group name. Load group name is going to be JackUp, and then we will specify that DZ on this node must be 0, and then we'll apply it. So you can see how the procedure is always the same. It doesn't matter which load you are applying, the procedure is always the same. Load case name and load group name. And now I can close this one. Once these are all set up, what's left for us to do is to actually do the construction stage, the construction stage sequence. So we will go back into our staging and have a look what to do. So click on the first stage, obviously, and click on Modify and Show. The difference from the previous, when we opened this window last time, there were no group or element or boundary groups in here. Now that we've created them, we can actually see them. So we said, let's say stage number one. In the stage number one, the deck, the first part of the deck and the pylon will be built. So I'm going to activate those two groups, pylon and deck. Based on what I said before, make sure that if the group contains concrete elements, the age is set up to a reasonable number, not 0, because otherwise the analysis is going to fail. So for the pylon and the deck, let's say the age when the concrete will start bearing some loading is 10 days. So we will add it to there. So now these two will be activated. Obviously, if we activated the elements, we need to make sure that the boundary conditions associated with those elements are activated as well. Otherwise, the structure is going to be singular and it's not going to converge. So which boundaries are related to those? Obviously, the one for the pylon. So we will switch to original and add it. And also the temporary ones, because the temporary elements the temporary supports are used to bear the weight of the deck. So let's add them there. Remember that there was a link in between the pylon and the deck. This one has to be activated as well. And also node number 1 has a support. So deck left is active. So these ones are all active. And once we are happy, then we move into loading. Which load is going to be active now? So we have just deck and pylon. Self-weight is the one to be activated. I could also choose a different day, but I'm happy to activate it on the first day. Once this is done, if you click on apply, the stage is going to be created. You can see straight away how all the information in the stage is then populated in the works tree menu, so you can actually check what you've done. Let's move on to stage 2. So let's now, well, we will have a look at the stages, how the structure looks like when we have done all the stages. Let's move into stage 2, starting from the elements. In stage 2, we are going to activate cable number 2. So the cable is activated. Obviously, the cable is a steel element, so we are not interested in setting up the age because there is no creep, shrinkage, no compressive strength development issue associated with specifying an age of 0. So we will leave it to 0 in this case. And in terms of boundary, we're not having anything else active, so we leave it as it is. Load, as we activated cable number 2, we are going to activate also stress it in the last stage and add and apply. So I'm going now to go through all the sequence and then we will see what the structure looks like. Stage number 3. In stage number 3, we will deactivate the temporary supports. So we're going to, we're not activating any elements, so this field will stay blank. Then we're going to move into boundary and deactivate the temporary. So I'm just going to select them in the group list and add them to deactivation. So they're going to be deactivated. In terms of loading, there is nothing that we are going to do at this stage, and then apply. Stage number 4, we activate cable 3, and consequently we will activate the the pre-tension load onto it. Add, apply. Stage 5, we will activate now the DC1. So load DC1 is activated and segment 1 is activated as well. And apply. Stage 6, we're going to activate deck 2. So we're going to go into the group. This is concrete, so 10. And we're going to deactivate the load segment 1. Because now the load segment 1 was to represent deck number 2. And I'm going to deactivate that. And apply. Stage 7, I'm going to activate cable number 1. And consequently, I'm going to activate the tension 1 at the last stage. And apply. Then it's in stage 8, cable number 4. Consequently, T4 as well at the last stage. Then stage 9, oh, sorry, I didn't click on apply. So element cable 4. T4 at the last. Stage number 9, no elements are activated, but then in terms of loading, we will activate DC2, so that's going to go here, segment 2, and deactivate DC1. And apply. Stage 10, it's time to activate deck 3. And we will deactivate segment 2 load. Almost finished on this one, and we got cable number 5, which is activated. And tension 5 is activated as well. Apply. Stage 12, we will activate DC3 and segment 3. And deactivate DC2. This is obviously related to the specific sequence, but it's obviously depending on the project, you can activate or deactivate different loads. Then stage number 13 is time to now activate deck 4, and we will deactivate the loading DC3 and segment 3. So DC3 and segment 3 are going to be deactivated. And in stage 14, always remember to click apply to save the changes that you've done. 14, we're going to activate in the boundaries, we're going to activate deck right. And in terms of loading, superimposed dead loads are going to be activated. We will apply. And in stage 15, just the JackUp loading is going to be activated. And apply. So this should be it in terms of defining the construction stage. So in any stage, you have to know what is active and what's been deactivated or activated. So the level of complexity obviously depends on the size of the structure. This was, I would say, even if it's a small cable stayed bridge, considering the construction sequence of a cable stayed bridge, it has this example is quite advanced as well, even if it's pretty basic at the same time. So now let's have a look. Let's close this window and let's have a look what the stages look like. So we got CS1, then CS2, CS3, CS4, 5, 6, 7, 8, 9, and so on. So at any time, based obviously on the inputs and groups that I have activated, the software is activating, basically switching on and off some of the loading or elements. And if you have a look, for example, at CS8, you can see how. Let's have a look at the nodal loads that I've applied. So if I just go into CS1 and then scroll. So in CS5, I have applied DC loading on node 12, and then that should get changed after. This is to show how even if the loading is assigned, the point load was assigned to the same load case, by assigning a different load group, then the construction stage treats those loads separately. And this is something that I want to sort of stress the importance on, because it's quite useful as a function. And now the construction stage analysis is ready to run. But let's say I want to change the sequence. What's going to happen? Or I want to change the way the structure is activated, or the stressing sequence as well. This is very, very easy to do. If you set up the groups in a way that can be easily rearranged as well. So for example, let's revert to the base model. Let's say that now I want to separate the construction of the pylon from the construction of the deck. One thing that we have to bear in mind is that this change, and every change you do in the model, can be done in the base model. So when you scroll through your load cases, and you want to do any change, just make sure you revert to the base model, because that's where you can change the parameters that you've input. So I will click again into define construction stages, and let's say now I want to do this change. So separating this construction of the pylon from the construction of the deck. So I'm going to add a previous stage. So the options available are insert previous or insert next. So if I click on CS1 and click on insert previous, the software is adding a stage before the one that I've selected. So now this one is going to be called CS0, let's say. And duration is going to be 10 days again. And I'm just going to click OK for the moment. What I have to make sure is to delete from the CS1 everything that I want to activate in CS0, because otherwise the software will not allow me to activate things which are already activated. So I will click on CS1, modify or show, and elements. So pylon is going to be moved into the other stage. So I'm just going to delete it. As a consequence, pylon boundary groups are going to be deleted from here, and the self-weight is going to be activated in the previous step. So I'm going to delete it from here, and then click on apply. Going back to CS0 now, I will activate the pylon, basically repeating the same process that I've done previously. And boundary, I'm just going to activate those. Load, SW1, add, and then apply. Let's see how the sequence has changed. If I go to CS0, now that's what's there. So this is the pylon with its boundary conditions and with the self-weight loading active. If I now scroll through the load cases and I go to CS1, obviously nothing looks changed because I've just added another step. And this can be done, for example, if I want to, let's say I want to stress all the cables at the very end. So I want to build everything, and then I want to stress the tendons at the very end, which is unlikely, but just for showing you how even very big changes in the model can be done quite easily, I will do it. So as we said, tendon, let's say we want to stress tendon number 4 and 5 together. So tendon number 4 was stressed at stage 8. So I'm just going to go to stage 8, modify and show. So cable 4 is activated here. T4 is activated there. I'm just going to delete it from here and apply. Then go into stage number 11, where T5 was active and activated at the same time. Sorry, at last. And apply. So when I now go into stage number 8, there is no tension 4. In the static load case, tension 4, there is nothing, which means there is no pre-tension load applied into the cable number 4. But then if I scroll to stage 11, those pre-tension loads, they are there, they are available. So what I'm doing is to change the stressing sequence of these cables by simply manipulating the groups in the construction stage and keeping everything that I've done as it was. This can be applied, for example, to changing the pre-stress loading on beams, on girders. So if you want to change the sequence of application of a pre-stress or post-tensioning load to a concrete section or a post-tensioned or pre-tensioned, you can do it at any time by simply manipulating the groups. So I think for the sake of this webinar, I'm just going to show you, as we have some minutes left, I'm just going to show you the last function, which is related to using construction stage analysis, and that's related to composite sections. So for composite sections, I'm going to go through an example. I'm going to show you an example of that. In this example, I've modeled a integral bridge. And you can see how the modeling takes into account the fact that the slab is cast at a different stage. So you can see how the slabs are activated in the section at a different stage from CS3. So CS2, only the girder. CS3, it's girders plus the slabs. How can this be done? So once you define the composite section that you will have to define previously, there is a function that you can call up, which is called composite section for construction stage. And this function will simply allow you to create a section property based on the section that the composite sections that you've defined. And it's quite easy to use because you will have to select the stage in which the first part of the section is activated. Let's say part 1 is always the girder, which can be either the concrete girder or the steel element in a steel composite beam. An active stage is going to be the stage when the element having this section property is activated. So let's say stage 1 or stage 2. Then the slab can be activated to a different stage. As you see here, there is a table that shows part 1 parameters and part 2 parameters. If I change the activation into CS3, then this slab is going to be activated at a different stage. This means that up until stage 2, the stiffness and properties of the section are going to be only the properties of the girder. And then at stage 3, the slab is going to be added in terms of weight, properties, stiffness, and etc. Something important to notice is that you can also change the material property of the slab within the same section and select it from different materials that you created. So now what we're doing is the girder will have the same material which is assigned to the elements in the main model, whereas the slab material is going to be changed to the one we specified in the table. And that's it. So once you do that, after having assigned the section property, then the software will be able to switch in between pre-composite stage and composite stage of the section. Now, I think for today, I covered quite a few things. And if you have any questions, you can contact me at uksupport@midasuser.com. If you have any, if you want more details or if you want to have a better understanding of it. Obviously, we are really keen to get any feedback on if you like the quality of the webinar, if it was interesting, if the subject was applicable to you. So any feedback is very welcome for us to improve the quality of them. And I thank you for your attention and your patience, and enjoy the rest of the day.